All right, hopefully, coming to no one as a surprise, we're going to implement a hash table. Yeah. But, hey look, there's already a trick. How many classes are we templating upon? Two. Not one, but two. So we're templating what the key and the value can be. Oh, great. All right, well, we just got to get used to templates. So in this one, we're going to do hash table via chaining. We haven't talked about open addressing, so we're going to stick with chaining in this one. We want to be able to initialize it with the set size, deconstruct it, be able to insert. Go ahead and print the thing. That'll be useful. Remove, and then get the operator. And you do need to implement two functions, hash code passing in an integer and hash code with a string, because I'm going to be testing those two, at least for your code. And hey, that's it. That's all the functions I want. They're right there. How hard can this be? No? Do a week from today. Don't forget to test your memory. Hey, we're going to start this in class. See, it even says class to begin to fill out.
So since we're learning open addressing next class, could we technically still use that on the lab, or should we not?
Use one on the lab, this lab. What do you mean?
The open addressing?
No, it works differently.
Okay.
You can definitely use parts of this, but it's going to work differently. You still have the array, it just gets rid of the linked list. But we will get to that. Right now, let's stick with an array of linked lists, because that'll be easier. So, what's the hash table going to be?
A key and the V value.
Okay.
Not sure if either would be a pointer.
Alright, your job's done.
What's that?
You're alright, your job's done.
All right, we got a key. But what's key's type is going to be K, not int. Yeah. Well,
K key.
capital K, because we're templating on K and V. I didn't call it T this time. Oh, tricky. Bless you. All right. So how many keys and values can this hash table hold?
Infinite.
Somewhat less than that.
A lot.
It's got size amount.
I guess that depends on your
Yeah, it's got
definition of a
size
lot.
amount patched in, so it's in size.
So I guess infinitely more than 0,
Well, how many,
or infinitely times more than 0. Sorry, infinitely times more than 0, but not infinitely more. Yeah. What's that?
like, for each index of the array, how many elements do we want?
What array?
What array?
I guess-
I don't see an array.
I guess.
Someone needs to make an array. Someone make an array.
Of what type?
That's a good question. What are we going to store in our array?
Both keys and values.
No, because it's linked list with chaining, which is an array of.
Keys.
It's an array of
Keys.
Buckets.
buckets, and those buckets are
Containing keys.
right, but the data structure that the bucket is
Linked list.
right. So it's an array of linked lists, and in those linked lists we are holding a
Key.
and
Value.
value. So we should probably wrap that in a
New type?
yeah, in a new type. So which part of that do you want to write first?
Making the new type.
The new type? All right, let's go above the class and someone make the new type. Template on class K and V.
I still put K and V there?
you do it just like down there. It's the same exact thing. Oh. 192.168.208.84. All right. What do we want to call this?
Hash node?
Hash node. That sounds great. You forgot your semicolon.
What's semicolon?
After
Like
the-
the class.
After the class. In C++, the class has to end with a semicolon. So
There's
after.
not one on the other one. Oh, at the
You want a
very
bet?
end.
You want to bet?
I thought you meant right after it said hash node.
Right there.
There was supposed to be.
Boom! Okay, great. Thank you. All right, so what's the hash node going to hold?
Linked list.
No, because it's a linked list of hash nodes, and the hash node is going to hold a key and a value.
Ah, that's it.
So let's put our keys and values in here. All right.
Why do we use the underscore again?
So I don't shadow the other variable.
So it's
Because if I didn't have the underscore, it'd be key equals key, which makes no sense. So I used an underscore in order to delineate that this was an argument and not the actual key of the class itself.
it's basically saying that.
What I just said.
No, I mean like this and that.
Yeah.
The
yeah,
opposite
yeah.
of this. You're saying that those are bad. And the pronoun getting fun.
All right.
Don't
Maybe
we
that'll
set
work.
those?
Maybe that won't. What's that?
Don't we have to set it too?
We do that in our constructor.
Do we
I
need a
thought
hash
we'd
node
do a
pointer?
set.
A pointer. What
Like
pointer?
Pointing to the next one if that may exist.
Oh, okay. We could encode our linked list here, or we could use the STL. Which one do you want?
STL, we don't have to do it, right?
Yes.
That one.
I don't know, I'm just used to doing a linked list by default.
No, we are going to use a linked list. All right, so we have our node, and I deleted all that because it's not what we need. So, again, how do we create our hash table? Okay. Let's think top down. You're thinking bottom up, which is good. But at the highest level, what's the top part of a hash table?
The head?
No. So I don't have the slides.
The array?
Yes, the array. So let's do the array, which in here is a vector. So std : vector. All right. Yeah, open or less than, because we got to put something in it. And what's it going to be a vector of?
Linked list.
All right, so that's called a list. So std : list.
Oh,
And then that list is composed of
the hash node.
hash node. All right, don't forget to close all your, yeah, there we go. Well, we got to give it a name. Hash table, because it's not an array. Sure, yeah, hash table. There we go. All right. So, does everyone understand this line?
Yes.
So someone repeat to me what it is, just to make sure.
It is a vector of type list of type hash node.
All right, good.
Called hash table.
Well, let's get rid of the rest of that, and let's see if it compiles. Nope. Oh, because the hash node is templated, right? So we need to pass the template that we have, key and value, to the hash node template.
So close.
There we go. Now it compiled. Hey, let's go look at some tests.
Yay.
Yeah. All right, insert test. Oh, I already started one. Hey, we can hash table an integer to an integer and we'll pass it 100. Okay. Then we'll insert 99 with 9001, and then we'll get 99. We should get back 9001. Does that make sense?
Mhm.
All right. Looks like I already wrote one. That was nice of me. Did we fail? Terribly. All right.
It's also not calling the right thing, so
Not
isn't that gonna make?
calling the. Oh, well, you mean that the.
HT,
No, no, no.
or does that make it?
HT is just what I called the hash table here. That's the class. That's the instance of the class. I call it HT.
Okay.
But internally to our class or our object, we call it hash table.
Okay. But we also haven't written insert.
Yeah, we haven't done
So-
anything. Yeah, we've been totally lazy. So we pass in a size. What do we do?
We create the array.
All right, but we've already created it.
So that's
So we need to. Let's see if we can load up good old Firefox. Or do y'all prefer Chrome? No Opera people?
someone go ahead and tell me if I'm wrong with that.
That what? Oh. All right, that looks good. If it ever loads.
Not on this internet.
This for some reason this site's always slow, and I don't know why. It's probably because it's running C++. Oh. Burn. Okay. No, C++ is usually much faster than other ones. All right. So you said resize.
Yep.
Do we have hey, look, change the size. Perfect. Yeah. Let's see if that worked. It didn't blow up. Okay, good. So now we need to be able to insert. Okay. Let me help you out. So remember this hash code, we have a function down here, hash code. If we're using an integer, it returns the key. String, you're going to have to do something. But right now we're just operating on integers. So we have a hash code, and it gives us back an index. Perfect. Now what do we do?
We also want to modulate based on size, but that sounds ridiculous.
Yeah, that's what you do. That's part of it. So go ahead, type that in. Sure. Where is size being stored? Because size isn't a variable. The size of what?
Right, okay. So this hash.
Let's see if we
table
have.
dot size.
Is it size? I don't remember.
It's size, I think. Go ahead and tell me if I'm wrong. Or the code.
It looks like you're right.
Who knows?
Okay. All right. Now what do we do?
We assign the key to that place, or we assign a new hash node at that place.
Oh, so we need to make a new hash node.
I
All right, let's do
think.
that.
Someone stop me if I'm wrong. So we have the key, we have the val. So hash.
I mean, we don't really have the value yet, right? Unless still have to go convert it to ASCII and stuff?
No, the val never changes. It's the key that we convert to an integer. Because the key is what's used in order to index into the array.
Well, the key's already an integer.
In this case, yes, but not in this code. In this code, it's templated. It could be an integer, it could be a string, it could be a whatever. It could be another vector.
Key was first,
not.
then val.
Let's not do that. Lowercase h.
Right.
All right. So let's do this. That way the node's created on the stack. All right,
Okay.
it's going to give us a huge error right there. Let's watch it.
Yay.
Missing template argument for node. Ooh, it even fails there too. Line 17. We probably should give it a key value, right? Actually, that's not where we want it. We want it right here. Ooh, that was close. There. That's much better. It's still going to blow up on us. Oh,
Really?
oh man. I can't even scroll up. Okay, the problem's right here. Hash table at this index, what do you have?
A bucket.
A bucket, which is a
List.
list. You can't set a list equal to a hash node. That's not what you meant to do. What do you mean to do instead?
Don't really remember into it basically.
Do what to it, sorry?
Add to it basically with like a pushback.
Oh, okay, add is what you said, yes.
Yeah.
Yeah, so whatever that function is when it comes up, hey, here it comes.
I don't know if any one of the other brainiacs in the room would like to say something.
Hey, so you got push back, pop back, push front. You can push the front or pop or push the back, whichever you prefer. Go for it.
You're accessing the list at that position, so I could just say.
All right. Yep. Go, go, go. All right, let's see what happens.
It still feels wrong.
Well, your feelings have betrayed you. Okay. There's well, how bad was that?
Is it? We're not done.
The only thing we're not done about is that this hash table returns true if you can, but if there's if there's already an object with that key, then you need to return false, because in this hash table you can only have one of them. So does anyone think about what you need to do next? We're not going to code that.
If key exists, but then you have to like find if it exists.
Right. Well, yeah. So you can, I'll let you think about that one. Oh, we can print it. We didn't do printing. Let's do printing, because then we need to see if we're actually doing this right. So let's do auto. I equals this. Let's see, what are we doing? Hash table iterator. Oops. I don't know why I did that. Hash table dot begin. I does not equal hash table dot end. I plus plus. And then we're going to do for auto j equals hook, because that would have been annoying. I dot begin, because you dereference that one, which jumps to the linked list. So we want the iterator of that, so that'll be the beginning. And while we're not at the end, j++. And then we can do, what is it? C out. We got j, so we want to call it, what are we going to call this thing? Star j dot get key.
Do we have a get key?
Yes.
Just make sure.
I call it val or value.
Value.
All right. I wonder if I typed that correctly. Let's find out. Almost. That's annoying that I can't tell what it says. Someone make their screen bigger. Who's the one that's
And to call a.
well, the problem is the error might be above it and I can't see. Because
Saying F
I can't
permissive.
scroll up right now in Tmux.
As this argument discards qualifiers F permissive.
Right. That's correct. Someone scroll up. Someone scroll, make it bigger. Who's got the short window? Who's got the tiny window? No one's got the tiny window? Alright, we'll do it the other way. Someone is lying to me. Alright, here's the error. Const required from here discards the oh man, we are discarding qualifiers all over the place.
Yay.
Nope, not right. I just checked.
No, these qualifiers are discarded. Line 30. Oh, wrong one. Oh, we're discarding our qualifiers here. Huh. How did that discard our qualifiers? That doesn't mean just, no, that's not discarding qualifiers. Alright, we'll get rid of our ampersands. Fine. Nope. Oh, passing const hash node as this argument. Oh, why is it const? So it wants this. That's what it's complaining about. And now it's going to say required binding const int to reference of type int discards the more qualifiers. No, it doesn't. Is it really going to be happy about that? I doubt it. Or it will be. Fine. Wow, C++. Because you don't want the reference if it's const because then cout could possibly change it even though it's not going to. Wow, that's dumb. Alright, well that was fun.
That's how I feel about
If you get rid of the
C++.
const and print, then it would have taken that as well.
Yeah, let's add some more numbers so we can actually see something.
Yay, we'll put them all at the same index.
Alright, what number do you want these to be? No, these are the indexes over here.
Oh,
If those are the
well, same
indexes, then
value.
they're exceeding the size of the AJ.
That's fine. Because
Okay.
we mod it, right?
Okay.
Remember, we're modding, so it loops around. So what number are we going to give it to 100?
It's so hard to remember that.
Alright, so wow, we're tired. Alright. Let's see if it prints it now. Hey, look at that. Hmm. Alright. And let's do one last thing. We'll go. Oh, that's kind of frustrating. There we go. There we go. Someone did it. Who did it? Do it again. Do it again. Come on. Alright, so I'm going to print off this way. I'm going to show you why in a moment, because it'll print off all the items in that linked list there, as well as all the other values, which apparently are not going to be allowed to be shown. So we've got 99. So if we do 199, 99, so we got a 299, then we'll do 399. Those are all going to the same place, right? Right. So there you see we have index 99, we have key 99, value 9001, key 399, value 9101, key 299, value, etc., etc., etc. All right, how are we doing?
Can we assign the 300 one first before the 2 and the 1?
They're pushing back.
We're pushing to the back.
Right.
Right, so the 99 went in there first, then 399, then 299, then 199, which if you look at our test, 99, 399, 299, 199.
Just confirming.
No problem.
What 80 something? Would it just go to 80?
Yeah, I'd go to 80.
Okay, just making sure.
All right, let's see how we're doing. Key, and I don't want to do the rest of this lab for you.
Why? What'd you do?
That's something I haven't heard in a long time. Yes.
You want
So
the
you made the
Why do you keep doing this?
you made the table pretty big. Do we need to make our table decently sized?
So notice that the size of the table is passed into the constructor. So I'm going to tell you.
When testing.
So when I test it, it has to be that size, because I'm going to test for certain things.
But when we're testing, should we test like a large one like you did, or should we test multiple different sizes?
You should test multiple different sizes, of course. But the bigger thing is make sure you test collisions, because we haven't done the get operation yet. I'm going to let y'all do that one. Or the collisions with insert. And then, is that it? Did I not do remove?
No.
We should only do it.
There's
when it's
remove.
required.
Perfect.
No menus.
Okay, look. Alright, since I did do remove, we'll at least get this one started. What's the beginning of this one? This one's going to totally fail. Oh man. Because there's an ampersand. And cout doesn't want you to get the ampersand. So we're going to have to do a little trick here so I can help you out. Because C++ is being dumb.
More than that. More than everything touches.
There. Make sure that you return get val ref and not this thing up here, because this is what these are the two cout ones. So this is what the actual code's going to want. All right. So how do we start this? You've done this before. It's right there. What? But you just had an extra hour of sleep.
Yesterday.
Wah, wah, wah.
Okay.
Don't worry, Turkey Day's coming.
Not soon enough.
Coma Day's coming.
And there's still new projects due. So.
Oh yeah. When's Project 3 due? Is it a week from this Wednesday?
Yeah, it was a week from this Wednesday.
Nice. Y'all have all started that,
Nice
bro.
to yourself.
Yeah. I'm just, keeping things moving. Keep things moving. Just keep it moving.
Never stopping.
Yeah, don't stop. Keep going. Yeah, so how is Project 3 coming?
Project what?
3. The third project. You haven't looked at it? Oh, you have. Okay, well, that's a start.
You haven't done anything. I just looked at it.
Oh, okay. Well, don't forget to do it.
do anything.
Hold on. Blake, what are you doing?
Why hasn't everyone stopped me until this point? I'm trying to iterate through the hash table, and then for every point of the hash table, iterate through a list.
All right, iterating through the hash table completely defeats the entire purpose of having the hash table.
No, we do the key mod, right?
Yes, we do the key mod, so we can just go to the point in the hash table, so we don't have to iterate through the hash table.
Yeah, fair enough.
So let's do
Someone
that.
type it, please, not me.
All right, so not me, hurry up and type it.
But we are gonna have to iterate through the link list.
Through the link list. All right, guys, let's just start this one over. You know, these things happen in life.
Let's just
All right, there we go.
delete everything. That's wrong.
Blake. Yeah. All right, so Blake gave it a good shot, and we made fun of him, so now it's someone else's turn.
Well, I'm also the only one typing, so I'll make fun of all of you.
He tried and then face first into a brick wall.
Yeah, that's fine.
Have to try that.
You know, guys, the code for this part is literally up there under insert. It's right. It's.
Sorry, I'm blind.
I don't even know what's happening right now, but we're gonna let this go. I just want to see what happens. I just can't wait.
Right now have brain past and stepped off the table.
So I'll be a face pretty much.
I can only think one thing at a time right now.
All right, all right, all right, all right, all right. So
I mean, it works.
we're on the right. No. We got some good things
Okay.
going on. We got some good things.
What is happening here?
We just didn't assign it to a variable size.
Well, also, what size? Where is size?
We don't have a size.
We don't have a size.
So it'd be a hash table size.
Yeah, hash table dot size. All right, I see where you're going with this. You're doing good.
Why is it in brackets too? What?
That's because the hash.
Sure that it sees it.
Yeah, it's because the hash table is actually an array. All right, now key may not be an integer, so how do we convert it to an integer?
Wait, what?
Key may not be an integer because it's
Oh,
of
you
type
need a
K.
hash code.
Yeah, we need to hash code that thing. So hash code that key. You can put it all in one line. It's cool.
Oh, it can be hash code.
Yeah, just put it all in one line. Why not?
That's
That way when you come back and you try and read it later, you'll be extra
Put
confused.
all of your code on one line.
You're bored and it's happening.
Yeah, no. It was.
No.
It's right up here. Hash code right up there.
Oh, I see it. It's fine.
All right, look at that. That's pretty. That's pretty. All right, now we need to assign a variable to that. Now it's not indexed because the hash. Remember, the hash table is composed of what? The array is a bunch of buckets, which are really just. Oh, call it a bucket. That's great. Call it a bucket. I like that bucket. But the Bucky, you could call it Bucky.
Bucky.
So, but the bucket's not an integer.
The bucket is a.
Bucket.
It's a linked list.
Oh, that was me. That works too.
All right, golf clap, golf clap, golf clap, golf clap. All right.
This is what happens when you tell us to code things.
Yeah, that's a dumpster fire waiting to happen there.
I'm gonna watch this later. Really cool. What?
All right, there you go.
I could do it.
Why do we need that? What is that for?
That's so you know what bucket's type is.
Oh, okay.
I was just telling you. I'm in golf clap for the auto because good choice. You know, using
Oh,
your.
good. I thought
you-
you
no,
were telling me I shouldn't.
No. Good choice because you know, using your resources.
Okay.
Before auto, you would have to type that all out, and it's a giant pain.
And then it would be even a longer one line.
Oh, but, well, yeah, so we should have typed it all out.
Please no.
All right. Okay, so we got our bucket. Now what do we need to do with our bucket? Maybe we are.
Find the bucket.
We need to what?
Find the bucket.
No, you already found the bucket. You're holding the bucket. You have the bucket.
We gotta go through the array.
Oh, now we gotta go through the bucket.
Is
All
this
right.
now where I implement?
Yeah, go for it, Blake. You got this.
Sure.
All your
What's
training.
All of your years of training.
have come down to this.
After this, you can die in peace.
I will never be at peace.
Life is war.
Oh, this is great.
Coding is war.
When is it not?
Fighting against the machines before we make the AI.
Before they make. I started watching The Matrix last night again, just for the fun of it.
I found out yesterday that.
Wait a minute.
What?
The Matrix was made in '99. When were you all born?
99, 98.
Wow.
96.
I also didn't realize until a couple years ago that movie's rated R.
Man, we had
Are
such
you letting
different
your kids
standards.
watch it? Is that what you know?
No. It just, I was watching, it was like, this movie's rated R. Like, what part of this is rated R?
That one.
Because they don't, I mean, they say a couple of curse words, but nothing that goes past PG-13. You know, there's some fight scenes, but there's not like blood and gore running everywhere. I don't think anyone even
And it's a list
bleeds.
of hash nodes.
What were we doing? Oh, key equals, yeah. So, remember, well, what's I? I is a pointer to,
The beginning of the bucket.
no,
The index.
no. What's the linked list made of?
Hash node.
Hash node. So I is a pointer to the current
Hash node.
hash node. Dot
Index, same thing.
I got you. Don't worry.
get key. Then what do we return?
Failures.
No, that means we found it.
Wait, that's what we're testing for, right?
Yes. Now what are we returning?
If we
False.
found it, then you would
We
return
didn't
false.
find it. It's not here.
We're returning a V.
Yeah, I know. Returning the get value.
I know.
Ref.
Whoa.
Get the semicolon out.
Get
Hush.
get that semicolon.
Hush, typing
Does this help
one-handed.
with insert too when we?
Possibly.
Yeah, that's what I was thinking.
Yes,
Like return
maybe. Can't prove that. All right. All right, let's go compile it now. Are we gonna get any errors? I'm trying to see. We might not.
false. Probably.
Errors? What are errors?
We passed! Oh, whoops. I pushed the button too
you broke
quickly.
it.
Hold on.
Dang it.
No hands. Hands off the keyboard. Okay, look, we passed.
So does it always put dot okay whenever it finishes?
Yeah, that means you succeeded.
I think it should be something more exciting.
Like,
You didn't fail.
congratulations, ASCII arts of explosions or
Yeah.
fireworks.
Yeah.
Oh, okay.
Yeah, like types in the turbo firework.
Final Fantasy victory music. Bum, 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 bum. All right, hold on. But we'll return if it's not in there.
False.
But we're returning a V reference. This is where things get very tricky. So I'm going to help you out.
False.
This is where it gets started.
Default. We'll call it def. And you just return def. Because def is just some default value, whatever it is.
Does
Make
that
it
need to
dead.
be a reference value?
When you return it, it automatically coerces it to a reference.
Just checking.
You will be a
Don't try and test for that. You'll be sad. All right. So if we're at, what should $3.99 get you?
9101.
All right. What should $2.99 get you?
9201.
And then what should $3.99 get you?
9301.
Man, we're doing amazing.
That's
You
it.
make that 199.
Oh, is it gonna fail?
He's gonna fail.
It's gonna fail. What do we fail?
You didn't make
The
it 199.
the 199 is not a 199. It is a 399.
Nice. All right.
Yay.
Nice.
Nice. All right. So we did a lot more. Now you get to do remove and insert. Actually, most of this has been done for you. Wow, that's certainly nice of me.
I think we should start remove now.
We should what?
Start remove now.
All right.
All in class.
So I'm going to clean that up and go ahead and commit it. Any other questions about hash tables?
How do we do remove?
Quickly and efficiently.
I like that answer. I like it.
Okay, and correctly.
That's a given.
Dang it.
I,
Yeah.
I want to make it
If it's
quick,
not anything, it
efficient,
has to be
fail.
correct.
Fail. I can do it. Return 1, always. Yeah!
Always.
All right. Any other questions, comments?
Sorry, screams.
Screams? So,
Tears.
tears. Remember to
Always.
put them in a bottle.
If we bring a bottle of tears, we get extra credit,
Define extra credit.
extra points.
I don't mind giving you points. If it's just not, points on your grade. I'll just give you random points. It'll be like, whose line is it anyways?
I love that show.
Yep.
I'd be like, here's a sticker, you won.
You won. Good job. Pat on the back.
You
Good job.
did it. Good job.
Good job. Good job, guys. All right. All right. Well, if there's no more questions, then I finished 10 minutes early. Go ahead and get started on your labs, and don't forget your project. Again, don't forget your project. I'm literally letting you use the internet on your project. Don't forget your project.